Welcome to Study Loop.
For this problem on the topic of waves and sound, we are told that a listener doubles their distance from a source that is emitting sound uniformly in all directions. If we are to assume there are no reflections, we want to know by how many decibels the sound intensity level will change. Now, we know the difference in sound intensity level, we'll call it beta 1, is equal to the sound intensity level at his new distance, which is twice the distance as his initial distance where his sound level is beta 1. And we can use the equation that beta 2 minus beta 1 is 10 decibels times the log of the intensity of sound I2 over the reference level I0 minus 10 decibels times the log of his intensity I1 at his initial distance over I0. And this can be written by using laws of logs as 10 decibels times the log of I2 over I0 all over I1 over I0, which simplifies into 10 dB times the log of I2 by I1. Now we have the ratio of intensities, but we need the distances. So we know that intensities can be written as the sound power divided by the area over which that power radiates. So beta 1 is equal to 10 decibels times the log, and now we'll replace the intensities with the sound power of the source P divided by 4 pi r 2 squared, where r2 is his second distance from the source, over the sound power P divided by the area, which is the spherical surface area, 4 pi r1 squared, where r1 is his initial distance from the source. So this becomes 10 dB times the log, and we can see with all the cancellations we are left with r1 squared over r2 squared. So we replace the ratio of the intensities with the ratio of the square of the distances. And we can write this as 10 decibels times the log of R1 over R2 all squared. Now again, using laws of logs, this can be written as 20 decibels, or 2 times 10 dB, times the log of R1 over R2. But we know that his second distance from the source is twice his initial distance. So if we put that in, we get this to be 20 decibels times the log of R1, and then he doubles his distance to 2R1, which means we're left with 20 decibels times log of a half. And so if we calculate this, we get the difference in sound level when he doubles his distance to the sound source to be minus 6 decibels. So the negative sign here indicates that the sound intensity level decreases.